Jay Shillington here on behalf of the NZXT Corporation, reminding you that if it doesn't say NZXT, it probably sucks.
In all seriousness, yes, this video is sponsored by NZXT, but it's not about NZXT products, to be honest. It is a video talking about AIOs, things to consider, different nuances of each type, especially as they've really progressed throughout the years. Kind of taking you a quick trip down memory lane of how we've gotten to where we are regarding all-in-one water coolers and how to choose the right one for you. This is going to be a very busy holiday season, I think, for a lot of people, either buying parts for themselves or trying to gift parts to people that they know are into computers and such and are trying to find the right product. So a huge thank you to NZXT for sponsoring today's video, but it's important to note this is not about buying NZXT products. We are just using them as some props in this instances. So let's go ahead and get started here. And the Jay Shillington character, I'm gonna roll with that. We're gonna build this character up together as time goes on. We're really gonna lean into that. I'm probably gonna get a little monocle. I'm gonna look like Mr. Peanut, okay? That's the idea by the end of all of this. I already got the booty for it, so we might as well go ahead and just really lean into it. Moving on, AIOs, all-in-one water cooling units. As water cooling got more popular, and when I say more popular, I mean, I'm talking like 25 years ago, it became important to try and really simplify it for people. Because if you wanted water or liquid cooling in your system, and back then it was actually very, very necessary, especially as multi-threading and multi-core CPUs started to become more prevalent. Moving on now 25 years later, things have definitely gotten more efficient, but we continue to see an efficiency rise and then a core count / speed rise, which brings temps back up, and then we go efficient, and then we go speed, and we go efficient. So it kind of looks like a swooping type of line as time goes on. We're now finding ourselves among 170 to 250 watt TDP CPUs now, which means unless you start buying bigger and bigger tower coolers, water cooling is starting to become somewhat relevant again, especially as we talk about big GPUs and stuff. But today we're focusing on CPUs and AIOs. So I digress. We needed to find a way as an industry to shrink the unit into a more singular, compact type of component. That one was easy to warranty because of the fact that it's one component. So if you were building a custom water loop, you had your pump, you had your reservoir, you had your tubing, your fittings, your block. And each one of those was a different component owned by more than likely a different manufacturer, sold at a different time, which means it was kind of a pain in the butt to just be able to utilize and feel peace of mind about it. So everything was shrunken down into what you kind of see here. Now, one of the earliest companies that really sort of patented this idea was AIOs, and that's probably a brand that you've heard of today. Many AIOs, almost all of them, there are exceptions, are based on the AIOs patent and design, which means that the company's paying a royalty to AIOs for use of the design, and then they can throw their own custom flair and nuances to it. And the actual patent is placed on the pump design itself. So not necessarily the whole unit, basically saying tubes attaching to a radiator. You can't really patent that because that's how you literally transfer the liquid. That's been around long before AIOs, but it's about the pump design. So anyway, with all that said, the earliest AIOs that we saw were actually single 120 millimeter radiators. That means you had a pump and a cold plate, or as you can see here, the cold plate would be the thing touching the thing you're cooling. So in this instance, almost all of them are using a copper cold plate with thermal paste touching the IHS of the CPU, transferring heat from the CPU to this unit, which is then transferring it through the heat exchanger, exchanging that heat to the atmosphere. But a 120 millimeter radiator, which basically means it had one single 120 millimeter fan on it, was about all you needed back then. I mean, we weren't talking extreme amounts of TDP or extreme frequencies or heat. As years went on, they started to find ways to make the radiators bigger. So as you can see here, this is a 240 millimeter radiator. This essentially, we'll talk about radiators first. That simply means how many fans of what size can you fit on there. So we've got two 120 millimeter fans or 240 millimeters worth of fan. It's important to note, and this is something people get wrong quite often, 240 millimeters is not the measurement of the length of the radiator. It's always going to be more than that because you have the end tank, which is where the fluid makes the turn to go back through. These are what's called double pass radiators. It means you can divide the radiator down the middle, unfold it and make it that long. That's technically the radiator space. It's just double pass, which means it's going through once, turning and coming back through again, where the same fans are cooling that fluid as it goes through. So by adding more radiator surface area, we're able to get better cooling, which increases the amount of TDP, or the amount of heat capacity that the entire system is able to have in it, the system in this instance being the AIO itself. Now, 240s were great, but people that were running custom loops and stuff typically use 240s or 360 millimeter radiators, which is what we have here. These are two 360 millimeter radiators that are basically identical. One's white, one's black. The only difference between these two units is the way that the pump is. We'll talk about the pumps in a second here. But almost all AIOs, for the longest time, were running 30 mil thick radiators. So that means the thickness and height of the radiator itself. That number has started to increase. You can only go so big or so long or so thick before you run out of space. So 360 millimeter tends to be the largest, really widely supported size. There are 420 millimeter radiators, which means it's running three 140 millimeter fans, but 360s and 240s tend to be the most common. But in order to get more surface area of the radiator, you can start to increase the thickness of the radiator, which means that you have more rows, it can fit more coolant in there, and it spends more time in the radiator, which is gonna give you more cooling, or at least more cooling capacity. Unfortunately, a lot of cases, unless you start accounting for the thicker radiator plus the fans, and fans have gotten thicker as well. Standard size of fans is 25 mil thick, standard size of radiator is 30 mil thick, giving you 55 millimeters of Z-axis clearance you need between wherever you're mounting it and any other component it might impact. Most commonly, the top of your case, plus the fan, plus any VRM sticking off your motherboard, that's typically what you would impact. Sometimes potentially RAM, if the RAM in your motherboard is mounted kind of high up on where they place it on the PCB. Fortunately, motherboard manufacturers have sort of caught on to this. So RAM isn't placed as high as it used to be. They tend to go with more denser heat sinks rather than taller heat sinks. And case manufacturers have started offsetting where the radiator gets mounted, meaning if the motherboard's here, they no longer go right above it, they offset it more towards the glass or the side panel to give you all this clearance right there. So this right here is a 280 millimeter radiator. So as I mentioned, that's the size of the fans. This is two 140 millimeter fans. So if we compare this to, say, a 240, you can see there's a pretty significant, I think the colors are kind of ironic too. Anyway, there's a pretty significant size difference between the white one and the black one. Actually, when I did our recent radiator test where I showed what is the actual cooling capacity of the 240 versus the 280, it was pretty eye-opening actually. The 280 is a very strong sweet spot in that you can fit a 280 in almost any case. It gives you pretty damn near the cooling capacity of a 360, but with better case support, right, and compatibility. You can see the 280 millimeter cooler very, very close to the 360, making it a very strong competitor. In fact, 280 has become sort of the most common size of AIOs these days. 420 does exist, which is just adding one more fan to this, but the case support for that is extremely minimal. Not a lot of cases will support a 420 millimeter AIO. Anyway, I can't put the list of compatibility right here in front of me. I guess I should have, but a lot of cases now are starting to be able to support a 420 millimeter radiator. In fact, my Antec Flux Pro does have a 420 millimeter radiator at the top. Okay, so that's about all you need to know for radiators. Let's go ahead and talk about the pumps. This is where the cost can become exponentially more expensive. All four of these radiators, or these AIOs, are utilizing a very similar cold plate design, but what you're gonna notice here is one of them particularly is going to look different than the others. You can see they're all copper cold plates, they're all roughly the same thickness, but you'll notice this guy over here actually has a larger cold plate, and it's thicker. The reason for this is as CPUs, especially the mainstream CPUs, have started to grow in core count size, they've started to become bigger. Ironically, AMD's Ryzen AM5 CPU IHS design actually shrunk versus what the older AM4 CPUs look like. However, Intel's got longer. So it's not just a square anymore, it's actually a long rectangle. So you have to make sure that you can get adequate coverage on top of the IHS, so the entire IHS is being touched, as well as trying to get the actual flow of the water going through the cold plate, which is just a bunch of milled fins in there to give it more surface area to touch the fluid to be able to transfer the heat. They need to be able to get the flow on top of the hottest point of the IHS, because it's actually the most efficient way of getting the heat transferred is to actually have the water flow move over the spot where it's going to be hottest. So if you were to take a look at a heat map of the CPUs, you'll notice that none of them, the heat is in the center. Older CPUs, yes, but with the new chiplet/tile design now that you find with AM5 and on 1851 Intel, You're gonna notice now that the heat is not in the center, it's off to the sides or wherever they have put the actual core arrangement. So now cooling manufacturers and AIO manufacturers are starting to look at ways to make brackets to place the cooler on the most beneficial part of the IHS to get the best cooling. So this is why if you're running some of the latest CPUs, let's say you're buying for yourself or someone that has like an AM5 9950X or a 7800X3D, 9000X3D, whatever, there's actually a different need in terms of where that cooler goes than someone running, say, an older AM4 platform, which is basically just centered essentially right in the middle. Even though it's chiplet design, they still have it very centered with IO die kind of off to the side. So the newer coolers are actually designed with these new hot spots in mind. So although you might find a really good deal on an older cooler, you might not be getting the most efficient transfer of heat if you're placing it on the newest socket, even if you're running the latest bracketry. Because the thing to consider too, even these coolers that came out prior to the latest sockets often have an available bracket that you can purchase or get for free from the brand that will allow you to mount it to a new motherboard and new socket type, but it won't be the most ideal situation. I will say this though, it's a test that we have coming up in the future where I'm gonna be testing an old cooler with a modern bracket versus the same type of cooler, let's say an NZXT like X63 versus the new Elite, same size, but with a proper bracket design with the new cooler to see how much temperature difference is there by having that more optimal placement and cold plate design. I'm curious if it's more than just a few C's of temperature. If it's only a few degrees, then really go with the cheaper option if money is a pinch. Now when it comes to the top, everything on the bottom is very, very similar in the way that it operates. The top of the CPU cooler, or in this instance, the block, is where things are going to differ. So what we have here is all of these have some sort of illumination, if you will, not to be confused with the animation company. So this guy right here, I think this is the old X63. I believe this is the X63, I could be wrong. This just has basically what's called an infinity mirror. So when it lights up, it has an RGB ring and a mirror behind it, so it just looks like it goes off into infinity. Fortunately, this guy can rotate, because for the longest time, if you had to put it in a certain direction, your logo might be upside down. So now you can just rotate that to get it going the right way. A lot of brands have really started to utilize that. Same thing with this guy right here. This one should also rotate. Yes, it does. So these two are essentially the same cooler. The difference is 360 and 280, as I already mentioned. But ways that you can also start to spend more money, if you're a fan of spending money, is by getting a cooler that has some sort of a screen on it. Sensor panels, screens, auxiliary screens somewhere in your system, they become extremely popular. And AIO brands have recognized, hey, users like to see on-the-fly data, which means if you're sitting there gaming and you're wondering, how hot is my GPU right now? If you can just glance over at your system and you see a GPU readout or a CPU readout or whatever readout you want to see, users like to see that. Now it's not as niche as it used to be. It's actually pretty common now for people to put screens in their systems, but it is a premium type of product, which means it's going to cost more money. That feature increases the cost of the cooler without any benefit to cooling. So if you're the kind of person that's like, I want form over function, then you're gonna want all the bells and whistles. The colors, you want the RGB, you're gonna want the screens and all that sort of stuff. But if you're like, I want all the function and I don't care about the form, then none of that stuff is going to be beneficial to you because it will be cost to no benefit. So that's the kind of stuff you have to start weighing, and this is what differentiates the price between coolers, because the radiator design, the tube design, the cold plate, all that, that's pretty consistent in terms of what it costs manufacturers to make it. But everything else that we're about to talk about here is where costs start to go up. So this is one of the earlier LCD screens that you would find on like an NZXT cooler. I believe this was a 2.6 inch screen. I could be wrong, can't remember the number off the top of my head. It has an LCD display on there that you could change to show, like I said, coolant temp. You can monitor the CPU temp. You can monitor the CPU usage, GPU temp, whatever you want. You could even split it sometimes where you can see CPU and GPU underneath each other. It's got a little gauge, it's kind of neat. You could put animated GIFs on there if you're just like, I'm doing a theme system, I want it to look like a fire or lava, whatever, space, kind of sky's the limit. Whatever video you can imagine, you could load a GIF onto there. Now the earlier versions didn't load video, but you could do a GIF. As the progressed and the technology got better on the software that can load information to the screen, videos started becoming a thing that you could load on there. So now what we have right here, this is the newest Kraken Elite 240 RGB.
Moving on to the slightly sponsored portion of the video.
That was not the right voice.
Jay Shillington here. There we go. This is the sponsored part of the video.
No, it's not really. Actually, this is pretty cool. It's the first time we opened it up and really took a look at it. It's a bigger screen, it does video. Resolution sizes, or resolution density is what's gonna differentiate some of these screens. This is a glossy screen, whereas that one, actually, is it glossy? Let me see, I haven't taken off the peel. It is a glossy screen. Now I gotta put that back on, because I don't wanna scratch it and get all dirty. Ooh, oh.
Nice.
Nailed it. Why, don't worry about it. Anyway, this one, like I said, it's got the larger cold plate on there. What's nice about this, and what you're gonna notice as we move forward on AIO technology, if you were to really start to compare them, these older pumps, as you can see, they have multiple harness locations. So you might have one that was having like a USB, micro USB or a mini USB, no, micro USB. So you might have a micro USB going to it for power or data to the USB port on your motherboard. You'd have another harness going to your fans and one going to your RGB and stuff, and it could get kind of ugly, actually. You'd have this nice pump on there and you plug in the wires and they're impossible to manage, or coming out on different sides and just gross. Even the later versions that you can see right here that have the first LCD from NZXT, it was a singular harness, but again, it was a harness coming out of the pump. But if we look at the latest version, these are actually wires that are hidden inside the tubing. This is becoming very common now for a lot of brands. There's no wires at all coming off of this AIO anywhere, because the harness, as you can see, plugs into this distribution block built into the radiator. They decided to take advantage of the height that they already know they have to have access for, because of the fans have to go there. See, it's the same height as the fan, so they're like, might as well utilize that space. Then this can more easily run behind your motherboard tray and to your controller and such, with no wires showing on the front side whatsoever. And then I do like that brands are starting to do this now. This is a fan frame, if you will. So this is a 240. They have a 360 as well. It's one unit that has both fans in it. There's RGB strips and everything in there on the inside, and the hub, of course, is gonna glow. You have this single harness. It is proprietary, so that means you can't use this on anything other than the NZXT hub that this works with. But it gives you one plug to plug in. And it's all controlled by the software, and it's just this one wire going to the hub, and then you've got this one main harness coming off the radiator to the hub. So it's a lot easier to install, and there's a lot less guesswork in terms of having to mount the fans on and all that. It's just super simple. So these caged fans, I love this. And you can buy these separately too. This isn't a Shilly sponsored part. I just want to point this out. You can buy these from many different brands now, and it just makes things kind of nice. The downside, because there's a downside to everything, if one fan starts to rattle or go bad, you got to replace all three, or all two, or whatever the cage may be. So that's where bearing type really matters. It's important to make sure you keep your system clean and free of dust as much as possible. The biggest reason fans fail is dust buildup in the bearings. And if it's not a serviceable bearing, then you're gonna end up with rattly fans. So there is that. This is why AIOs are costing more now. Any sort of custom feature like this, they have to run a wire through a sleeve. This is all done by hand. This is not done by machine, like running the cables through the sleeves and stuff. If a human has to touch it in assembly, that makes the cost go up exponentially at the factory. You start to have to make these little blocks right here with the custom harnesses, everything that is just different than the mass-produced products that exist adds cost. So that's definitely a trade-off when it comes to the all-in-one water cooling units, where you can now have $300+ AIOs because you're now having all these little extra conveniences and nuances that are built into them. One other thing I should mention when it comes to AIOs that is highly important in my opinion is going to be the warranty. All AIOs will fail without question. Just like every produced product in the planet will fail at some point. Everything fails. Ask me, I should know. So the warranty is very important, and I feel every AIO should carry at least a 5-year warranty. The reason for that is 5 years tends to be the point at which, if the radiator is not serviceable or refillable, that's about the point where evaporation that does take place These are sealed units, but they are not completely sealed from the environment. The environment is an amazing thing in terms of, life finds a way. Well, the environment finds a way to pull the moisture out of this because the moisture wants to move to the air. That's evaporation, right? So at some point, some of this fluid is going to get replaced by air. And once that air starts to reach its way to the pump, that is when you're going to start noticing that your temperatures are rising, your pump is more noisy, and it's time to replace it. If it's serviceable, meaning it has a little fill port or something on the top, if you were to be able to get this to the right orientation, pop the fitting off, top it off, screw it back down. The electronics would be the thing that fails before anything goes bad in this. And the electronics would probably outlive any of the corrosion of any of this metals and stuff in here. That's another thing we should talk about too, just a mention. Every single one of these units nowadays are using an anti-corrosive type of fluid that is specifically formulated, or should be, to the mixed metals that exist in these. Because all of these radiators, not all AIO radiators, but some of the AIO radiators these days are copper now, but they're mixed metals. Aluminum with copper, probably some stainless steel in there somewhere from some fittings or plugs or something. Mixed metals leads to galvanic corrosion. And having all this electricity so close to it helps accelerate that galvanic corrosion. So that is what was leading to the failure of a lot of earlier AIOs, where companies were not accounting for that. They were just throwing in whatever glycol-based coolant that they could get for mass quantities, and then corrosion would happen and the impellers would fail, or they would straight up generate leaks somewhere because it could eat through the aluminum or something. So fortunately, the mixed metals are something that have chemically figured out today, which is also why it's very important, if you have a coolant or a radiator that allows you to top it off, that you're using the proper coolant. Because if you use the wrong coolant, or you just use water or whatever, you've just accelerated whatever process is potentially happening in there when it comes to failures. So that's kind of it. It's not complicated when it comes to AIOs. If I had to put a hierarchy to the importance, I would put at the top a tie between having the right size radiator for the type of CPU that you're cooling. So if you're going with like a 14900K, a 285K, a 7950X, a 9950X, and you have the high core count, high clock speeds, can generate some heat CPUs, I would highly recommend a 280 or a 360. I would also recommend that you're getting a cooler that is specifically designed for the type of CPU that you're using. What that means is, like I said, not using an older cooler that says now includes blah, blah, blah bracket, because if it says that, then you know it was an older one that has a new bracket with it. I would just recommend buying the newest cooler that is designed for whatever socket it is that you're using. And they always advertise it. They always advertise like optimized for AM5 or whatever. Obviously check the reviews to see how they're performing so you can make sure you're not getting one that just has that marketing material all over it. But I can tell you with the AIO brands I've talked to, they all have done a ridiculous amount of testing of moving around and just by millimeters at a time where that cold plate is touching to find the most optimal location, while giving you also the most compatibility with making sure the tubes are not hitting RAM sticks or VRMs or any of that, because you only have so much space you can work with around the socket. The next thing I'd make sure is that the warranty is a solid one. There's brands that stand by their product, and there's some brands that don't stand by their product. So obviously check customer reviews to see how their warranty process has gone. That is just as important as how good the product is how well do they support their product if something happens along the way that requires an RMA. Beyond that, everything else are nice to haves and not need to haves. Some of my favorite AIOs that exist are the dumbest, doesn't have any special features type of AIOs. They just have their mounting bracket. You mount down the pump. You plug the pump into a SATA. There's no controller. It just plugs into the motherboard and you control it through the motherboard and you're up and running in 10 minutes and you have no programming or software to download or whatever. Those are my favorite AIOs. But with people building systems now that are about being flashy and pretty, which I know so many of you are against and hate, and that's okay. There's nothing wrong with that, because on the flip side, those that like flashy systems can't understand why you don't care about a flashy system. So isn't it funny how that works? It's kind of a two-way road when it comes to opinions, huh? If you're gonna give one, you gotta accept one. Those options exist for everybody. And if you don't care about the art, like for instance, the fans that come with these X63 and X73s, you'll notice if you look at the box, there's no RGB anywhere on the fans or anything. It's just this ring right here. And you can simply not plug that RGB cable in if you don't want it. That's what's nice to have about RGB as well, is you can change the color on the fly or turn it off entirely. Screens, 100% subjective on whether that's important to you. Just know those make the cost go up pretty quickly. And the amount of cables and software needed is guaranteed to not be excessive, but you're gonna have cables and you're gonna have software that has to run to make this stuff work. All right, there you go. Hope that gives you some things to consider and think about when it comes to AIOs. Oh, one last thing to mention. Some brands out there specifically sell an Intel version and an AMD version for the reasons I mentioned about the placement of the pump and design being specific to the socket that it's going on. Double check that you're not buying the wrong one. That is a thing that has started over the last couple of generations of CPUs, and it's catching a lot of people off guard that they're buying an Intel one and trying to put it on AMD and vice versa. So anyway, all right, there we go. What is your best buying tip for anyone that's shopping AIOs? This holiday season, I have no doubt there's gonna be a lot of people looking at this sort of stuff, because I think we're gonna be moving into a pretty strong 2025 in terms of people building gaming PCs and stuff again, because we are entering into that 5-year cycle since people have really kind of gone into upgrading in 2019 when it was really popular. Now we're gonna be in that 5-6 year cycle, and I think that a lot of people are gonna be shopping for this stuff. So there you go. Best buying tip you have down below. Maybe I'll pin the best one. Thanks for watching, guys, and as always, we'll see you in the next one.
NJ Shillington here, also saying thanks for the money.